Whether you're running a farm, a factory, or even a city's water supply, getting a handle on water quality can be a real headache. It's usually a mess of different sensors, wires everywhere, and tons of data to sort through. But what if? What if you could do it all with just one single powerful device? Well, today we're going to break down a solution that claims to do exactly that.
So first, let's really get into the weeds on the problem. Picture this. You need to know exactly what's going on with the water in a deep well, miles from anywhere. Or maybe inside a corrosive tank in an industrial plant. Just getting that data, especially in real time, is a logistical nightmare.
Think about it. For a deep well or some industrial outflow, you'd normally need a whole bunch of different instruments, maybe miles of wiring, and then you've got to somehow sync up all that data. It's just super inefficient, and honestly, it's a recipe for errors. The big question has always been, how do we get the full picture, but simply?
And that is exactly where this new kind of approach comes into play. What if you could just replace that entire complicated setup with one integrated device? Let's take a look at how it actually works. Okay, here it is. This is that all-in-one sensor we're talking about. It was designed from the ground up to tackle those exact challenges by packing multiple functions into just one unit. The whole goal is to totally streamline how we analyze water quality.
So here's the magic. It's not just measuring the water level. At the very same time, it's also measuring four other crucial things. Electrical conductivity, or EC, which basically tells you about the dissolved salts. Then you've got total dissolved solids, or TDS, which measures all the mineral and organic stuff in there. And on top of that, it gets you temperature and salinity. That's 5 critical data points from one device, all in real time. Now that is efficiency.
Of course, a fancy sensor is totally useless if it can't actually survive out in the field, right? So let's dig into how this thing is built for the real world.
The design philosophy here really boils down to 3 things. First, it's got to be durable enough to handle some really harsh conditions. Second, the power and data connections have to be simple and super secure. And third, once it's installed, it needs to just work, reliably and consistently. It's all about making it practical for day-to-day use.
And you can really see how this plays out in the design. The different sensor probes are all physically built into one unit, which makes installation so much easier. You've got these waterproof connectors, which means setup is fast and secure, even if you're in a wet and messy environment. The whole thing is made to be deployed fast, and if you ever need to replace it, that's easy too, so you have almost no downtime.
Now, this quote from the documentation points to a really key feature. It uses PTFE, which you probably know better as Teflon, for its electrodes. And what that means is the sensor is incredibly resistant to corrosion from acids and alkalis, so you can stick it in some really harsh environments, like industrial wastewater or agricultural runoff, and it's not going to degrade.
And the specs absolutely back this up. It can operate from a freezing -30 all the way up to a blistering 80 degrees Celsius. It can handle pretty much any climate you throw at it. Its 10-meter measuring range is perfect for those deep wells we were talking about. And maybe most importantly, that plus or minus 1% accuracy means you're getting data you can actually trust to make critical decisions.
Okay, so you have a great sensor that can survive anything. But that's useless if you can't get the data out, right? So now, let's look at how this device fits into a complete data system.
This is where the flexibility really shines. It supports all these industry-standard outputs, like RS-485 for digital communication and those 4 to 20 milliamp analog signals. What that really means is it's designed to just plug and play with the PLCs, data loggers, and control systems that companies are probably already using. No compatibility headaches.
And the connectivity doesn't stop there. You can pair this sensor with all sorts of wireless modules. 4G, Wi-Fi, or even LoRaWAN, which is this awesome long-range, low-power network that's perfect for remote sites. Just imagine getting real-time data from a well that's miles away, streaming directly to your computer. You could even hook up a solar panel and have a totally self-sufficient off-grid monitoring station. So when you have a sensor this tough, with data options this flexible, where does it actually fit in? Well, the range of applications is just incredibly broad.
This list here just gives you a little taste of the possibilities. You're talking about everything from environmental protection in huge aquaculture farms, all the way to making sure things are pure in food and pharmaceutical production. And of course, it's critical for managing industrial processes in things like metallurgy and chemical plants. Its versatility is really its superpower.
So what's the bottom line here? This sensor is designed to turn chaos into clarity.
It takes a complex, messy, multi-device problem and replaces it with a single, elegant solution. It simplifies your installation, it boosts reliability, and it delivers 5 critical data points right where you need them when you need them.
Ultimately, by making the whole process of gathering data so much simpler, a tool like this